Now there are some built-in functions in R, and we'll quickly have a look at all of these functions. So as we had already seen, the log function, that is the natural logarithm to the base, right, and that value which was passed was 10, and the value we got when you executed this code with an enter was 2.302585, right. Now if you want to do an exponential, so you will say exp, that's the function for exponential, and you'll pass the value. So the exponent of 1 is 2.7182, that's how we'll read it, right. Now a couple of other functions. So log x does log to the base e of x, that's a natural logarithm. Exp of x says antilog of x, that is the exponent, so it's e raised to x. Log of x, the function log with the first parameter an x and the second parameter as n, wherein you are saying what is the n. So if you want the base to be 2, you will say the n is 2. If you want the base to be 10, you will pass that as a 10, right. You similarly have log 10 of x, which says log to the base 10 of x. If you have to do a square root of any number or a variable, you will just pass that in the square root function. So x is some vector which has some values. If you pass that to the square root function, it will compute the square root of that term. Similarly, you can compute factorial x, so it will give you the factor, and floor x will give you the, it will basically do a rounding job. So if you have something like 2.4, and if you say floor 2.4, it will give you 2. If you give ceiling, it will give you the upper version. So it's like rounding to the least one or rounding to the top one. So 2.4, if you pass in the ceiling, it will give you a value 3. Truncation can be done with trunc x, so closest integer to x between x and 0. So whatever is the value pass over there, it will truncate it and it will return that value. Similarly, you have round. So there are, and also one thing to observe is there are multiple functions to do the same thing in R, right. So you can have a round x with digits mentioned by default as 0, which if you mention as round digits is equal to 2, so it will show in decimal values 2.42. If you say digits is equal to 3, it will do 2.432, whatever is the rest value. Then you have sign if x comma digit is equal to 6 gives x to 6 digits in a scientific notation, right. So basically some output which you get from the scientific calculator can be done using this also. If you want to create a vector of random numbers, you can use the R uniform, that is random number from a uniform distribution, and n is the number you want. So how many numbers you want, that you specify over there. Cos x is for cosine function, sin e is for the sine function, tan e is for the tan function, right. So take a tangent, so cosine of x in radians, sine of x in radians, and tangents of x in radians, that's how we'll read it. And ABS stands for absolute value. So if you have a signage in between, so if you pass absolute of -2, you will get the returned value as 2. It will just remove the sign over there, negative, something like a modulo. Numbers with exponents. For every big number or very small number, R uses the follows scheme, right. So for example, if you have a typical linear regression model, right, so when you're trying to look at the output of that model, it will specify some of the parameters in terms of very small numbers, and R has a habit of displaying very small numbers by using the term e with some number. So if it's an E3, it means that it's 10, it's 1000, that's how you have to read. If it is E minus 3, it means 1 by 1000, that's how you will read it, right. So it would typically be something like a 10 by 10 raised to 3, that's how you have to read it. So 1.9 e raised to 3 means it's 1900, which is represented on the screen with a 1.9 into e raised to 3. So you just multiply by that 1000 and it becomes the actual 1900. That's how you have to see this. So now we come to modulo and integer quotients. Now you have 200, the modulo sign is represented with a percent and a percent again, right. So to know the integer part of a division, say how many ones are there, 11s are there in 200, right, not ones, 11s in 200. You will just do a division of 200 by 11, right. So if you do this, right, what you will typically be getting is the division aspect, so some decimal value, right. But here in our intention would be to get the division and the remainder portion. So you put the modulo operator just in front of the division sign, and then after that, and that's where you're getting it as 18. To know the remainder portion, you will just remove the division sign, right. You'll just type 200 modulo modulo that's a percent sign, that's represented as modulo, and you say 11 and you get it as 2. That's how you will see it. Now if you are doing a multiplication or even a division for that matter, and you get some output, right, and you are interested in only an whole number and not in a decimal value, now you have certain known rules, right? So you can have something like, okay, do you want it closest to the lowest value? So in a 3.7, right, if you want to round it to the highest possible number, it would be 4. If you want to round it to the lowest, it would be 4. So there are functions like floor and ceiling. So when you say floor 3.7, it returns you 3. On the contrary, if you say ceiling 3.7, it returns you 4.